All right, so let's look at some problem solving with the Poisson distribution. So what we have here is College Pro Painting does home interior and exterior painting. The company uses inexperienced painters, so they do not always do a high quality job. They believe that their printing or painting process can be described by a Poisson distribution with an average of 4.8 defects per 400 square feet of painting. So this is typical of Poisson, where we have an expected number of something per. It could be a time measurement, a space measurement, a distance measurement, something like that, where we can't really measure the failures as easily as we can measure the successes. So here a success is going to be a defect. Now what you might remember is the Poisson probability formula is this right here that's written out, where lambda t is the expected number of successes in time interval t. Now, time is, of course, a loose term here. It could be, like I said before, it could be space, it could be distance, it could be whatever. So, let's look at solving some probabilities. And what I'm going to do is introduce you to some Excel functions. That way, it's a little bit easier. Because otherwise, we'll be here for a long time calculating probability calculations. So, looking here, we have the probability that a 400 square foot painted section, so same baseline, 400 square feet. So that means that our mean rate right now is 4.8. We want to have fewer than 5 blemishes. So in probability notation, we want the probability that our random variable x is less than 5, which means I am fine with having 0 successes, 1 success, all the way up to 4, not including 5, right? Now in Excel, we have a function that's called Poisson dot dist. And what goes first is the number of successes. Now, if it's cumulative, we use the highest number of successes. We then put in the mean rate, which is 4.8. So I'm going to call this x. I'm going to call this lambda t. And the last entry is whether or not we're using cumulative. We've seen this before with binomial. That is true. And when you put that into Excel, the final answer should be 0.4763. So having up to 4 successes, up to 4 blemishes would be almost a 50% probability. So same size painted section. We want the probability of exactly 3. Well, that means probability that x equals 3. Now, you could just as easily use the probability formula if you want to, but we'll use Excel. So this is, again, Poisson.dist. And it still starts off the same way. We want 3 successes. Mean rate is 4.8. But this time we're going to put false in the last entry because we're not looking for a cumulative probability this time. We just want a single probability. And when you compute that, you should have 0.1517. Okay. Now here is where the fun begins. We're going to switch up the mean rate. We're going to look at a 1,000 square foot painted section. And we want the probability of having more than 10 blemishes. So to find the new mean rate, let's just do a little calculation off to the side here. We know that it's 4.8 blemishes per 400 square feet. So we want to know how many it is per 1,000 square feet. So that means that our mean rate is 4.8 over 400 times 1,000, which comes out to be 12. So that means that we're gonna use that as our mean rate now. Now here, let's just look at another thing though. We want more than 10 blemishes. Well, that means we want anything from 11 and above, which means that never stops. So we're kind of in a pickle here because our probability function only gives us up to a value or exactly a value. So what do? Well, let's look at the opposite side of the distribution here. We know that the sum of all probabilities in a distribution is 1. We are leaving out all the stuff that comes before 11. So we know that this probability is equal to 1 minus 0, 1, and up to 10. Which is 1 minus, we'll call it Poisson dot dist. And again, the same kind of thing happens. We're going up to 10. Our mean rate is 12. And it is cumulative. And what that equals to, it should be 0.6528. So there we have that. Now, going back to the baseline, let's look at an extension here. So now we're going to randomly select 6 different 400 square foot plots. And what we want to know is what is the probability that each one, or I should say all of them, will have 7 or fewer blemishes. So let's concentrate first on the probability that one of them has fewer than 7. Well, that we already know because we did a problem like that before. Poisson dot dist. So first comes the number of successes that we're going up to, and that's 7. Our mean rate is back to 4.8 because we're talking about 400 square feet again. And this time it is true because it is cumulative. That piece of it, and I'm rounding to a little bit more decimal places here because we're going to be doing more calculations with it. So we want to preserve some more accuracy here. So there's that probability. So if that's the probability of one 400 square foot patch having 7 or fewer blemishes, now what's the probability that all 6 of them do? Well, you might remember from before that if they're assuming they're all independent of each other, we know that that's just going to be 0.886666 for the first one and the second one and the third one and the fourth and the fifth and the sixth. So we just raise that to the 6th power. And that comes out to be 0.4859. So there is, getting a little bit more problem solving in there with the Poisson distribution. So I hope you found this helpful, and I thank you for watching.